Philosophical up in here. And we are live. Hello, live listeners. Welcome to Go Time Pre-Show.
Yes.
And make sure you guys can hear my soundboard because that's pretty much the only reason I'm here.
I can hear everyone.
Still says we're 2 minutes out, so we're not gonna start the show before 3 o'clock. So otherwise, people will get kind of upset that we're early.
Yeah.
So,
I was upset at the airport because they started boarding one of the flights early, like 3 minutes early. I showed up. I said, "What are you guys doing?" Trying to get here right on time so I can look cool and just walk on the plane. And
messing with my mojo.
You're messing with my mojo.
Yeah. I'm trying to slide my way into this here cabin, and
the whole thing.
You are making me wait, pausing my stride.
Like when you have a house guest who shows up too early and you're like, being late is kind of rude, but being too early can also be rude if you're not prepared. And you're like, they're here. And I'm still wearing my slippers or whatever you guys have to do.
We don't have that problem in Miami because you always give somebody the time 1 hour early.
Oh.
The time on an invitation in Miami is when you're supposed to jump in the shower and start to get ready.
Really?
Not the time you're supposed to show up. So all my friends have to constantly tell me that like the invitation is not gringo time, it's Latin time.
All right. So how would it work? So let's say I want you to show up at 8 p.m. I give you 7 p.m. or give you 9?
Yeah, you put 7 p.m. on the invitation.
Because everyone shows up an hour late to everything generally?
That's what time people start to like think about getting in the shower and getting ready. Unless you're a gringo, then you have to say 8:30.
Okay.
If you want.
Wow, this is all too confusing.
Trust me, 25 years of learning all this. So I know when it's a Latin party, I personally reach out and I say, is that what time you want people there? Or is that Latin time? And then they'll let me know. Because
if you showed up 7 p.m., you'd be early.
Dude, I've shown up. My first year in Miami, I got invited to like a baptism. And the invitation said it's like 4 o'clock or something. And I got there at 4 and my friend's like, "What are you doing here?" I said, "It says 4 o'clock." They weren't even setting up yet for the party. So I helped set up.
There you go.
No,
it's like they build it in. They build in the tardiness.
Yeah.
That sounds a lot like Black people time, where it's just like
CP time.
Whenever, yeah.
That's Black people time, gay people time.
I've never loved that term.
It's not a great term
because my family will tell you, like, if we're like late for something, I get BS, like I get all like
punctual,
hot and bothered. Yeah, like probably because I kept hearing CP time, color people time, and I'm like, forget this nonsense. Like, I'm showing up early, I'm showing up on time. I'm not with that nonsense. But yeah. And then I eased off a little bit, it's like live a little bit, stop
live a little bit, show up a little late.
Thing. My dad is the chronically early type. He's like always 15 minutes before whatever it is, like doctor's appointment, gets there 15 minutes early. I did not inherit that. I am the chronically late person. I'm like, it says 2 o'clock. It's fine if I get there at 2:05. No problem.
No, 2:05 is still within that range of, like, maybe I missed the elevator on the way up, or
right.
Like it's still relatively, you're still on time. That's even 2:10 is like fashionably late. 2:15, then I'm like, okay, maybe you didn't time this right. You didn't plan this right. 2:30, like if I'm like waiting for you on something, I'm out. Like I'm like half an hour. No, I don't have that patience.
When it comes to business, I've gone to a meeting that I was supposed to have at noon with somebody who I needed because I'm trying to sell like this person as a client. And it would be like 10 minutes later and I'd walk out. I remember walking out. The guy saw me. He was in some other meeting. It's 12:10. I walked out. And all of a sudden I get a call from him like 5 minutes later. I'm in the parking lot. I said, "Where did you go?" I said, "We had a meeting at noon. It's now 12:15. I go, I don't know who you think you're doing business
Right.
with, but I don't do this.
Right.
Now the guy starts apologizing, like, and he's like, come back up, come back. I go, are you out
Now
of your
he's
meeting?
selling you. Now he's selling you. Now you got him right where you want him, right?
I know, right? It's a strategy. I don't know, Bill. That sounds like a tactic.
And I've known the guy now for like a decade, and we've done a little business together. But I don't know. I don't. That bothers me to no end.
Yeah, the 15-minute late to a meeting thing, that bothers me.
Me too.
I'm not waiting past 15 minutes.
I want to be right at the right time, and if I'm not, something went wrong. You know, that's just how I've always been. I don't know why, but I will wait. But I'm with you, Bill. I think once the 15-minute, I mean, you said 10 minutes you were gone. I'll usually, and we do a lot of interviews, you know, so like there are times where people do or don't make their interview. And Adam and I'll sit here and like 12:10 or 2:10, usually in that case, we'll send an email over. Hey, we're waiting in the like 15 after. Yeah, we're gone.
Reschedule if you care to.
Yeah,
Right.
exactly. I missed it.
There's some things you can be late for, and there's other things. I feel like social things. That's when like the
Like, hey, we're all
time where
meeting at
it's-
the bar at 8 p.m. and you're like, well, if I'm there at 8:30,
Right. Yeah.
no big deal.
Yeah. Exactly.
the
No,
business stuff.
my favorite thing is I worked for a guy that was like, he ran a $5 billion mining company. Okay. And he's had this tactic. And one day I finally asked him because I couldn't take it anymore. You go into his office to have a meeting. And if it was an important meeting where he needed to really negotiate, he'd turn the temperature down in the office to like 60 degrees, super cold. And he got used to the temperature being that cold, but it would put the other person behind the desk just so uncomfortable that he could basically own them in the meeting.
Power moves.
It was, oh my God, power moves. Like, it was unbelievable.
Would he have a chair that's higher than your chair as well until you have to look up to him the entire time? That's another lame power move people do.
No, he didn't do that. He strategically put things on his desk so he could see what you were trying to look at times. Like, but the cold temperature thing was always like, because I finally asked him one day, I said, why is it so cold in here? And he started laughing. This is why,
Wow.
Bill.
Was it like a maniacal Dr. Evil laugh? Because that's what I'm imagining right now. Mwahaha.
This guy was impressive, man. All right, let's go.
Speaking of late, yeah, now I'm making us late by chit-chatting. Let me make sure you guys can hear this.
Bars and kilobytes.
You heard that?
Yep.
Mhm.
All right, cool. So we're all set. Then I'll turn off my video here. I will.
You could join us again.
I'm dying to, but I'm not going to. I'm going to hold back.
Dude, what whatever it is, it can wait, right? You gotta live a little.
Come on, guys. This is like I'm too old for peer pressure, you know. But it's working on me. I need to get off this call.
We're like down a person. We need.
You
we need
already,
another person.
yeah. Plus, you've already. I mean, we started like 5 minutes ago. You've been on the show. People already saw you on the.
I don't know anything about Golang.
Nah, man.
I
We're
still
talking
call
about
it-
design and philosophy.
I still call it Golang. I know you're not even supposed to, but I just do.
No, it's
You know?
an easy mistake to make. It's fine. It's fine. Come on.
No, I actually do know not to do that. I just did it on purpose to be funny. No, I got too much to do. And besides, we want Bill to have as much airtime as possible on this particular episode. So
The fourth person is going to come from Slack, Johnny. That's it.
there you go.
Slack is the fourth.
Slack is the fourth. So there you go. Slack room.
We'll monitor the
Holler.
Slacks.
By the way, real quick, if you are watching live on YouTube and you're wondering why there's no chat, it's because Gophers hang out in the Gophers Slack. And so there's a Go Time FM channel. We want all the chat to be there, not on YouTube. So that's why there is no chat on YouTube. So if you're there, head over there instead and chat. Okay, that's all for me. I'm going to play your intro song, Johnny, and I'll be here listening, participating in the chat as I also do other things. All right, here we go.
Let's do it. It's go time.
Hello and welcome to this episode of Go Time. I'm your host, Johnny Barsico. If you haven't heard me on the show for a little while, that's because I've been taking a bit of time. I'm smelling the roses and taking care of family in the home front. But I'm happy to be back today with a nice meaty topic, I think, and a special guest as well that I'll introduce momentarily here. But joining me today to co-host is Chris Brendow. Hello, Chris.
Hey, Johnny, how's it going?
It goes. I'm feeling I wouldn't say totally refreshed, but I've it's good to take some time to sort of be grateful for things and sort of recollect yourself, kind of thing. But yeah, that's where I'm at. That's my state of mind right now. Yeah. So speaking of state of mind, I'm very happy to have on the show today Mr. Bill Kennedy. That's a name that you'll probably recognize if you've been in the Go community for any length of time, really. Bill writes a ton of blog posts and teaches, runs workshops, manages the Go Developer Network, along with a cadre of other folks. So, Bill, welcome to the show. How are you?
Thank you for having me. After hearing that, I'm a little tired myself, Johnny. I think I'm going to tag out and you come in and I'll go out.
Yeah, I'm telling you, it's time to take stock. And today, actually, I'd like us to spend some time talking about, or rather, taking stock of design philosophy. It's kind of nebulous topic. If you hear about philosophy, like what does that mean? Like what am I supposed to do with that? I'm an engineer. I'm a software developer. Like we're all about the precision and things. So philosophy can feel a little mushy, right? So today I'd like us to sort of unpack that a little bit, and obviously contextualize that with the Go programming language. But I'm sure we're going to spill beyond that as well. So what I'd like to do really is to let's frame what we mean by design philosophy. What do you mean by that, Bill?
So the idea of design philosophy came to me as I was learning Go and started studying lots of other people that came before me in terms of their thoughts and opinions on how to write software. And I collected all of these quotes that I have a document that I tend to share every once in a while on Twitter. We'll get that in the show notes. I kind of gathered all of these different thoughts and ideas and integrated them all together into my own kind of design philosophy on how to engineer things. So for me, design philosophy is actually something that's very concrete, it's opinionated, and it's really based on a collective of ideas that I think work together. And I also think it is so important when you're engineering to have a design philosophy for everything, because that's what you're going to hit up against when you start to have the engineering conversations around guidelines and idioms. But when you're lost and you're not sure what the right answer is, I always fall back to, well, what are our design philosophies here? And are we violating any of them? Or which ones keep us more in line with the way we want to do things as opposed to not?
Is a design philosophy the same thing as sort of a like architecture or like planning software? Are these things like synonymous, or are you thinking something different?
So let me give you a small example. I'll give you my two foundational design philosophies. Right? These are in the basement. They set the foundation for everything. And when you don't have anything more specific to lean on, you lean on one of these two things. So number one, we don't make things easy to do. We make things easy to understand. That's a design philosophy. We can bang that up against micro level decisions. We can bang that up against macro level. When I say macro, I mean that architecture and things like that. So we always focus on easy to understand, not easy to do. And the second one is really about precision. Everything we do, every encapsulation that we define, whether that's a type or a function or everything we do must define a new semantic, some new behavior where one is absolutely precise. And this idea of precision-based semantics for me drives a lot of the decisions that we'll make. So I had a conversation with my business partner today, right? And you'll hear me talk all the time, functions over methods, functions over methods. Why? Because a function can always be more precise than a method. And when you have the opportunity to use the function, and we're very clear about what the parameter list is and the return argument, and you're being precise, well, my design philosophy says that let's go functions over methods every single time. That's at a micro level. At a macro level, for me, it's about layering. Can we be precise around what layers of code we're going to have in this project so we can maintain a mental model around these things, right? So these are base design philosophies, but then we can add to it, right? In the study, in that document that we'll share, there was a study that basically said, 2 studies over 30 years or something, it basically said nobody can maintain more than 5 things in their head at any given time. So now I have a design philosophy around the idea that when we're layering things and we're doing things, let's try to keep it at around 3, because then we know that we can keep it in our head. So my project structures have 3 layers. And if you want layers inside of that, they really can't be more than 3. If you get to 5, that's fine. You get over 5, we know what's about to happen. And so the design philosophies are there to guide your decision-making in the guidelines, in the structure. And then allows you during code review. I catch things in code review because my brain goes, we're failing a design philosophy here. Why, how, what are we doing? And you can start to smell decisions you're making just from that alone.
Chris, I'm curious to get your opinion as well. As what do you think of? Where does your mind go when you hear design philosophy?
I think I actually been thinking about this like a bit in the past couple days, and I kind of feel like it's a like a high level umbrella term for me when it is applied to software engineering, right? So I feel like, as Bill was saying, there's multiple layers to it. So I feel like at one layer there is this software design, and then at another layer there's code design, and I feel like those are 2 different things in my mind. And I feel like, I don't know, I feel like the principles of each are kind of, in some ways, they pull against each other, but in some ways they are collaborative. And I guess I'll extrapolate that a little bit. So when I think of software design, I think of kind of timeless, higher level things that, doesn't matter what programming language you're using. If I pull from distributed systems, I'll say, things like the CAP theorem, or, using specific levels of consistency for specific types of problems you want to solve, right? You don't have to write in Go to have a linearizable system. You can write in any language. And I think when I think about design, I think about the tension of that compared to the tension of us wanting to write it's kind of like high quality, lower level code. Like, all right, we have this design philosophy of like, okay, well, we've decided this system fits well with linearizability, but we're now using a language that is more difficult to use linearizability correctly in. So should we be using it there? Or should we be trying to maybe change the high level design that we're doing so that it fits better with the code design level things that we want to do? So I feel like design philosophy is fundamentally about those types of trade-offs at both the code and the software level, and thinking rather deeply about those types of trade-offs and coming up with nuanced solutions to them. And I definitely agree with Bill that I think that keeping things to small buckets is best. Like, you don't want to have people like look at something and have to memorize 7 things or remember 7 things or 9 things or 10 things. It's not going to work out very well. And I think that in order to do that, you have to start with something much larger and distill down over time. So I think like a core part of design philosophy for me is just start with kind of flailing around, figuring out what is the thing you're trying to build, and then distill it down. And once you've distilled it down into, okay, here are my 3 points, here are my 4 points, then you've actually got something that you can then kind of progress forward. So that was a very jumbled answer.
No, like I want to tie that back into what Bill was saying. I hear those definitions or those takes on design philosophy, and I can't help but notice that there is no there's no precision to it. Like you can't lent for that, right? Like Bill was talking about like a code smell earlier, right? In a pull request, right? You're looking at that code, you're like, well, that goes counter to our philosophy, right? So it's something that seems like you kind of have to get used to designing a certain way, get used to sort of layering your systems a certain way. And if you work on Bill's team, that team's design philosophy is going to be different perhaps from my team or your team, Chris. So it doesn't seem like it's something that's universal. It's more like this is what this person or this team or this company, this is what they believe works best for them. That is their approach to design. That is their approach, right, to building systems, right? Am I missing the point here, Bill?
I take it even down to the project, which for me, every repo of code is a project. And this is why I get nervous when every developer has their own repo of code, because every repo or project represents the philosophies and policies that code has to follow. And so I'm always in a less is more. Can we put more developers and put more things in this one repo or project? Because then we're going to have a more consistent, right, policy set for more of the code that we're working on. Here, and to me, philosophy and policy kind of come into play. I have 3 layers for a project structure. The last layer being, I call it the foundation layer. I can think of it as like the standard library for the project, right? It's code that needs to be as highly reusable and potentially code that could be reused in other projects, even though it belongs here. Now, what we can do is set design philosophy and policies around this layer. So one policy I have on code that sits inside of foundation is that is code that's not allowed to log. Not allowed to log. I see you pass a logger to any package in the foundation layer, code review is going to stop. We set this strong policy. Logging is a business concern because the project has to decide what logger they need, whether it's structured or not, what the purpose is. That's not foundational code. That's not code that can be reused across projects. And so for me, the design philosophy is setting the policies for, at a macro level sometimes, what code can do at a certain layer, or it defines the syntax we're going to use. So here's something else, right? At a micro level of code, I have a really a guideline that says if you're constructing a value to a variable, you're not to use pointer semantic construction. I don't want to see the use of the ampersand operator on a construction that's being assigned to a variable, mainly because construction in Go doesn't tell you anything about where the value is going to be placed in memory, right? Escape analysis, how it's shared. So the ampersand operator, for me, is one of the most important micro level operators we have to readability. Because if I see return ampersand U, I know, well, there it is, that's being shared up. I can look at that one line of code and know exactly what the cost is, right? Readability is about understanding the cost of things. But if I move that ampersand to the construction call and I just say return U, oh, dude, how much readability did I just lose, right? So my design philosophy is that when we talk about readability, there's 2 aspects of it, a subjective one and a measurable one. The measurable one being that every line of code should not hide the cost of what it's doing. That's a design philosophy. Every line of code should not hide the cost of what it is, because as soon as you start to hide the cost, you can't look at a line of code and make an engineering decision. If you understand the cost, then you're engineering. And so now we apply it to a guideline. Don't do pointer semantic construction to a variable because you're moving the ampersand at the top of the function when it should be somewhere else. And now somebody says, well, Bill, what do you want me to type ampersand U 4 times because I've got APIs where I've got to share that? And I say, absolutely, I want you to have ampersand U 4 times because it's not about making things easy to do. It's about making things easy to understand. Boom. So do you see how all of these kind of philosophies kick in at different levels from a micro and a macro level? And I've studied for a long time the thoughts of a lot of people to integrate all these kind of ideas together. And a lot of the people that I've studied tended to be in and around, I'd say, Rob Pike and Rob Griesemer, Bell Labs, other language designers. And so I always felt like there was this common theme among a lot of these people that I also kind of see and go and then can apply to go. But hopefully that gives you another kind of idea of where things are going. And so when I see a particular syntax, or I see I'm not able to understand the cost of something, it starts to like trickle in my brain. Okay, we need to refactor something here to get back to these ideas.
It sounds like there are, in some cases, there are some things there are some hard and fast rules that you can apply, and things that you can look for, always sort of a rather returning a pointer, right? At the return site, right? Having that ampersand in front of something, as opposed to having it where you actually declare the thing. That's one hard and fast rule. I'm wondering, what are some other hard and fast rules that you have, and like syntactically in Go code, that are part of your design philosophy?
I have a whole set of kind of philosophies around the idea that you start programming in the sense that you're trying to get something to work. You always are in a programming mode at the beginning. Let me just find some code. I don't care what it looks like. Let me get something to work. And then for me, you have to move into an engineering frame of mind, even if it's prototype work. Some of the most dangerous programming I see is the code that somebody does and hands it off to somebody else, thinking that they're going to now do the engineering piece, and they don't. And that code ends up in production. And so there's a bunch of kind of philosophies around moving from programming to engineering, right? So look, Wes Dyer said this: make it correct, make it clear, make it concise, make it fast, right? But those are 4 steps. To me, those are 4 different refactorings that you have to do to a piece of code.
In that order.
In Wes's world, it's in that order. And I agree with Wes, right? But there's other refactorings you should be doing for code. Make it precise. He might be saying make it concise, right? And I think he means precision there. Can we make the API cleaner, right? Can we make the API more precise in terms of what we need? And then to me, there's a piece that is lost too. There's a refactoring piece about making something testable, right? And I think sometimes people start with the idea that this is going to be testable. No, what does it mean for something? It's a refactoring piece. I've worked on a function for 3 hours with somebody where we made it correct, we made it clear, we made it concise. And then they thought, wow, this is great. I said, yeah, this is great, but it's not testable yet. We need to refactor this to make this testable. We need to think about how we can do that without having to add an interface, without having to add an abstraction, without having to do some of the things that we kind of, right? So a design philosophy for me is this. You write things in the concrete first, then you ask, does that need to be polymorphic? Does that require an abstraction layer? In other words, can that function continue to ask for data based on what it is? Or is there a reason why it needs to ask for data based on what it can do? And I think too many of us default to the idea that everything should be asking based on what it can do. And I say, no, that's an engineering cost. First of all, it's an allocation out of the box. And second, it's an abstraction that doesn't necessarily make our lives better. So it's a stage, right? And sometimes the answer is yes, this is a situation where we should be decoupling the code. And there's times where we say, no, we only have one implementation of this. So let's not do something for the sake of doing it. That's another design philosophy. Let's not do something for the sake of doing it. Let's not make things polymorphic for the sake of leveraging interfaces. Let's refactor that. And I'm always talking about complexity cost, right? Don't make something complex until you absolutely have no choice. That's a design philosophy, right? If something can be single threaded and it's fast enough, why the heck do you want to make it multi-threaded? That's an order of magnitude more complexity, right? And I think sometimes people feel pressed to show that they can do these things, or they're bored and they want to do these things, or they're being asked to do these things without any real engineering understanding behind it. So these are kind of philosophies where if somebody comes up and they're like, okay, we're gonna start throwing channels at this, and we're gonna start going channels, slow down, right? Let's not add the complexity until we absolutely need it. Prove to me that we need it.
Do
So
you?
it's, yeah.
So I'm absorbing this, and I'm thinking your approach to designing software then is you're going to be looking at you might have some core sort of fundamentals that sort of transcend a particular project, but you're going to be taking a sort of a fresh look and approach to every project. In other words, where I'm going with this is that you have philosophies that are sort of part and parcel to using a framework, or using some APIs, or using a particular set of packages, or and whatnot, right? So these things have encoded the philosophy of the designers of those sort of common pieces, right, that you can take from project to project. So if you're starting a project today, and the last 2 or 3 or 4 projects that you used a particular framework that does it makes life easy, right? and I can kind of guess where you're gonna take me with this, but it makes things easy to get going and to see results right away, right? Like, are we doing it wrong, right, for wanting to sort of run to the things that we know and perhaps love, and the things that make it easy to get going, right, without thinking of anew, right, about a problem that we're trying to solve, right? Like, where does the having a design philosophy forces you to sort of sit down and think of everything fresh, or can you sort of take a shortcut, right, and reuse things that have worked in the past?
I think you need to reuse the things that are already bound within your design philosophies that you have. You're not going to write everything from scratch. So I have a repo out there called Service. I teach people from beginning to end. How do we write production level services in Go? We basically pair program that from beginning to end. And the entire 5 days is me saying why I'm doing something. And I think that's the key. Your design philosophies and guidelines come out of the why. I think comments in code should be the why when the why is not obvious. And I published that service repo project specifically for it to not be a framework, but to be what I call a starter kit. Because I feel like frameworks can add value, like you're saying, but you're locked in to the walls related to that framework, right? Because you're not really coding at that point as much as you're plug and playing inside whatever those endpoints are that they give you. I didn't want that. I didn't want another framework. I want people to be able to engineer from the ground up, not necessarily have to start from the ground up, but be able to, if they have to, get back down into those layers. That's where the starter kit's about. So I teach from beginning to end, every package, every layer, why we're doing it, the constraints that I have that you may not. You're going to have different constraints that are going to require you to have different engineering choices, which doesn't mean that you're violating a design philosophy as much as you now have to. I'll give you an example. I'll give you a perfect example. My first version of the business layer for this project, user package, products package, right? Your entity type packages. We're using functions. I had this conversation with Ed today. I think it's a classic example of where multiple people can do different things and still be bound to the same design philosophies and guidelines. It's all about where you are in a project. So I first had functions. Now, at that time, every function needed a database connection, because we have a design philosophy that at the business layer, the context should be empty and those functions should work. If you've got business level packages and code that require something in the context to work, you're in a lot of trouble. That design philosophy for me is a critical one. So we're not going to hide database connections in a context at the business layer API. You're assuming that then only web-based apps are using the business layer. No, I could write a CLI tool. I could write a UI tool today, right? And now they don't know that they're supposed to stick database connections. It doesn't work, right? So the original design of a function in the business layer was context, because that should come first, database connection, and then whatever 2 or 3 other things you needed in order to execute a query against the database, okay? If it was a create or an update. So about 3 weeks ago, I decided that I wanted to start logging the SQL query that was executing. Now, if you're able to do that, if it's not a privacy violation, which it could be in some shops, this is when we talk about different constraints. I have always loved logging the SQL queries, because if there was a bug, I could just copy and paste it out of the log, and I'm not wasting 10, 15, 20 minutes trying to reconstruct it, right? And now you got to be smart about which ones you're logging and so, but minus that, I want to start logging. So now, if I want to start logging the SQL query, I need to pass a logger in. So I start passing a logger in with the database connection on the function signature. Highly precision. Like we talk about precision, this is precise. Some functions have 7 or 8 parameters at this point, but I don't necessarily mind that because of the precision. But I'm sitting back and I'm looking at this API of about 8 functions, and I start to realize that passing the log and the DB in, which is mandatory across this entire API set, is no longer giving me the precision I want. Those 2 parameters are starting to be noise, because technically, even though I need them, it's not really relevant to performing a correct or create or an update. And my brain said, even though it's precise in terms of the parameter list, these 2 parameters are starting to create noise for me. So what did I do? I said, let me prototype the idea of turning these into methods. Since the log and the database connections instantiated one time, we don't need to instantiate on every request. And I can also move these into methods, and a value of this type only has to be instantiated once at the beginning of the program. What I could do is move the database and the log into as a receiver access and make the APIs precise again and get rid of the noise, which I did. And for me, it worked out. But then Ed looked at that and he says, Bill, you're breaking your design philosophy around precision. Isn't it more precise if you pass it in? I said, yes, let's just say it is, except look at the entire API set. Look how this is kind of noise. We only instantiate all of this one time. If I had to instantiate this for every single request, the answer would be, nope, sorry, gotta live with it. We're passing it in. But because the method set, the type bound to the method set only has to be constructed once at startup. Like now I just reduced the noise out of the API. And from my perspective, I think I'm maintaining better precision. Now that's subjective, but we can all have that engineering conversation. And that's what I want our teams to be having. Those are the best ones. Let's debate if this is more precise than that. And then we'll make a decision. This is where I'm going to. This is why you need design philosophy, because if not, you're not making the best decisions. Now the conversation we're having is subjective, but it's objective to the rule of precision. And we can all kind of weigh in on what we think is, right? And Ed and I both agreed that probably what I'm doing in my scenario, because I now want logging, was more precise. But if I wasn't going to log, like I wasn't earlier, I wouldn't do that. I just pass a DB connection in, because you see where I'm going. But when I'm working with teams or I'm working with people at Arden and they come up with me questions about, Bill, should I do this or should I do that? I always start every conversation with, okay, let's list out the design philosophies that we think apply to what you're trying to do. And that always seems to do 2 things. One, it helps guide the conversation we're having. And then everybody kind of just comes together and says, okay, based on that, this is the best approach. I just find it really works also in a team environment to have that.
This actually lines up quite nicely with a question we got on the GoTime Slack channel. Should I design for the problem I have to solve today, right? Or for the harder problems I might have to solve tomorrow? This is on Abdelkader on Slack.
So here's more design philosophy, okay? Tomorrow is not promised. So you should be writing code that you need today, not tomorrow. I cannot tell you, unfortunately, the handful of times in my life where I walked into work and was told they just let go of the CTO. Everybody stop what you're doing. If your product's already in production, maintain it. If not, you're done until the new CTO comes in and decides what she wants to do, right? And now you're in limbo for 2 weeks. And then they hire the new CTO, and now you lose another month. And most likely, if your product is not in production, it's done, it's over with. And so from a design philosophy, I'm always about the idea of let's just write the code we need now. And let's get this into production. You know that term technical debt, you know what it means to me? Everybody has a different meaning, right? But I can tie it to design philosophy around it. Technical debt to me is every day a piece of code is sitting on your laptop and not in production. That's technical debt. I am hiring you to solve a problem. That problem is not being solved on your desk. That problem is being solved in production. So if you're not getting that code in production, what am I paying you for? I think sometimes, and now, you know, own my own business and all that, but I think sometimes people forget, like, you're being paid to generate or help to generate revenue for the company, so I can pay you at some point. Even if you're not directly related to revenue, you have to be somehow related. You just can't be a cost center your whole life. Somebody's got to look at you and say, okay, even though I can't directly relate it to the last dollar we made, their time is helping maybe somebody else, right? So you got to be conscious of the fact that you're being paid to solve problems. Problems are solved in production. Whatever that production environment is for you, there is one. And so you need to be just writing the code you need today, including the abstractions you need today, because tomorrow is not promised at any level. And you adding more code because you think this is going to come businesses shift all the time. And what's funny about that and this question actually comes from this idea that you should be writing less code anyway. So NASA did a study. Some people may have heard me say this before. NASA did a study of all of the software that they wrote. Now, you know, they're writing pretty technical C-level kind of code, but minus that. Their study came up with the idea that the industry average number of bugs is about 15 to 50 bugs per 1,000 lines of code. So I equate that to basically, and I want people to put this math in their head because I do. Every 20 lines of code you write, there's a bug in your software, whether it shows up or not. So if you want to write less bugs, the math is simple.
Right, less software.
Now, when we talk about Go, what was Go? One of Go's language design philosophies was being able to do more with less code. It's coming from these, I believe. Okay, I can't speak for Robert, but I believe it's coming from these ideas that if there's less code you need to write, there's going to be less bugs. Now, why do they say this, right? Because Strauss-Up says, if you're writing more code than you need, it results in ugly, large, and slow code, where ugly means you're leaving places for bugs to hide. Large means you're ensuring incomplete test coverage. And slow means you now start to make shortcuts and dirty tricks away from your frameworks and your patterns because you're moving fast and the code gets out of control. And these things absolutely happen, okay? And so I think, like, we're talking about all of this, it all works together, and I think Go is tied into that. You know, and we complain about Go's error handling, right? We love to complain about it. But do you know that there was a study done where they looked at 48 critical failures that brought down systems, hundreds of bugs in Cassandra, HBase, MapReduce, Redis. How many systems run on Redis today? Okay, and they found in this study that out of those 48 critical failures, 92% of them could have been avoided if error handling was done better. Failures from bad error handling. Failures from bad error handling. So again, I think that the Go designers knew this. They knew this because they were developers themselves. They were not necessarily academics. They had to build software. They knew what the average developer needed. They knew where they were falling down, right? And I think Go comes in and solves these things. And when, personally, I think somebody complains about error handling in Go, they're complaining about they want it easier to do, not easier to understand, right? We come back again, right? And so sometimes, and make things easier to understand, things have to be a little more tedious. But here's another design philosophy, Johnny. Two of them, okay? One, you shouldn't be writing code for yourself. you should be writing code for the next person that has to come along, because if you don't, if you're not thinking about the next person and or the average developer on your team, when you leave, that code base leaves with you. It gets replaced. And the 3, 4, 5 years you spent on that ends up resulting in meaning nothing. I've got code that's 20 something years old, 10 something years old in production right now. The 20-year-old code should go because that's way too long. But I think it's there because I always wrote code with the understanding that somebody else has to be able to maintain this. It wasn't about me, it was about the next person. And that allows that code to now not just have to be replaced, right? You need to have kind of like that design philosophy in your head. You need to be thinking about that. Who's the next person that's going to come along here? And then you're always writing code for the average developer on your team. If you're the average developer on your team, that means I can wake you up at 3 in the morning, God forbid, if I have to, and you can handle the bug. That's the average developer. If I can't wake you up at 3 in the morning, then you're below average. So now the question is, why are you below average? Is it because I'm failing you, or are you just not coming up to speed? And then for me, the next thing is the above average developer. That's scary because those are the developers that tend to get bored. And instead of being able to write for the average developer or bring the team up, right? That's where the clever code comes in. That's where we trip up. And I tell people all the time, when you're hiring, evaluate who this person is for your team. Are they below? Are they average? Or are they above? And consciously understand what you're going to need to do as an individual and a team to get this person in the right place. If they're below average, which is great, let's hire developers who are below average for our teams so we can bring them up and we can create a stronger team. Those are the best developers in the world because you can really teach and train them. And now you've got somebody who will stay a long time and really work hard, and thank you for the opportunity. Like you put me on a team that's doing business APIs, I'm above average. You put me on a team doing crypto, I'm below average. And if I wanted to learn crypto and you gave me that chance, I would be ecstatic, right? And I'd work hard and we'd get there. But if you're hiring somebody who's above, and I've done it before, they can either be amazing mentors and coaches, which is why you're hiring them, I hope, or they can create utter chaos and destruction because everything they're doing is not comprehensible to anybody else on the team. And you've got to maintain it. So those are design philosophies around building teams, right? Mm-hmm. Around the ideas of all of this stuff. And you want to apply it back to micro level decisions like construction, functions versus methods, to macro level decisions around app layer, business layer, foundation layers of code, policies for these layers, import policies, error handling policies. Who can shut down an application? Who can't? Who can log? Who can't? Who can wrap errors? Who can't? Who can set certain import dependencies? Who can't? Right? And you don't have to have all of it day one. You have to develop it as suddenly there's a hole in the engineering decision. We don't know what to do here. Okay, that means that we may not have a design philosophy. I get excited when that happens. But I'm like, oh my God, we don't have a design philosophy for this. Oh my God, we get to do something new. Woo! Now, you always got some of your base foundational, right? But those are exciting days. And it's also exciting sometimes when somebody finds a hole in a design philosophy or a policy where we thought this was the right thing to do, and suddenly we found an exception. And there's exceptions to everything. There are some exceptions you just can't take. I don't really take exceptions between project layers, okay? I will never let the foundational layer log. Like there's no exception to that. If you're at a log, you're in the business, that's it. But then there are other exceptions. Okay, here's a good one, John. Here's a good one where you might take an exception, okay? So baseline design philosophy. A type system is not to be shared. A type system exists to allow a package, which is a unit of code in Go, a clearly compiled time unit of code. A type system is designed to allow data to flow in and out of the package API, where a package has a purpose, right? So if the type system's job is to allow data, right, here's my philosophy, right? If you agree with this, you don't have to agree with anything I'm saying today, by the way. It's totally fair. But if you believe that a type system's job is to allow data to flow in and out of a package, then that type system is highly localized to that package and that package only. So now you have to make a decision about every API. When it comes to data flowing into an API, you have two choices. You could say, I want the API to accept data based on what it is. This is what I would call a concrete function. It's accepting a concrete type. It can accept a user and only a user. That's what it is. But thanks to interfaces, we can write polymorphic functions that say, no, this API will accept concrete data based on what it can do, right? And that's the next level of refactoring, hopefully. I don't want to start there, but suddenly you realize not only can I work with a user, I can also work with a customer based on this common behavior. We make it polymorphic. Okay, we all agree with that. You have both choices, and those are the only two choices you have. And those type systems, those types should exist as types within the scope of that package. Now, here's where the fun begins. I have a strong rule that functions should only return concrete values. That a function's job is not to pre-decouple or wrap concrete data already in an interface. That is not the API's responsibility. It is the caller's responsibility to decide whether or not they need the decoupling or not mine. So minus the error interface, which is a whole nother set of interesting design philosophies and things I have, right? Mm-hmm. I don't want to see a function that uses http.handler as the return type. I don't care if you know or think they're going to put it into a handler already. I don't care. It's not my job. My job is to give them the concrete value that they can then do with what they want. Well, Bill, then we're leaking no, you're not leaking a type. They already imported your package. There's no leaking there. What are you talking about? Stop trying to abstract for the caller. Let them do it. Now, there are two exceptions to this, right? One is the error interface. We're handling errors in a decoupled state. There's lots of reasons why I want to do that. And until 118 comes out, there are times where you might need the empty interface. It should be a little bit of a smell, but let's be real. I've had to write a function or two over the last 6 years where I was trying to be, for whatever good reason, generic. Maybe I was just doing some data flow, and we were using the empty interface, which now in 118, we'll be able to replace with what? A concrete type. I mean, what is generics at the end of the day anyway, right? Generics is concrete polymorphic functions, where the polymorphism isn't happening at runtime. The polymorphism is happening at compile time, right? We're choosing the concrete type, the data, because the only data that flows is concrete data anyway. We're just choosing that at compile time. It's for me, it's concrete polymorphism as opposed to runtime polymorphism, right? But there's a philosophy. We shouldn't be using the interface as a return type, minus those two exceptions when they happen. And people disagree with me there, but there it is. So if I see a function that's returning an interface, it's immediately code review stops. What are we doing? Why are we doing this? Prove to me that we need to take an exception, but it's going to be hard because if I return the concrete type, that doesn't prevent the caller from doing whatever it is they're doing.
I feel like there's this kind of like high level or this overarching theme of kind of shifting focus away from the code so much and shifting it more toward the software and the process. I guess what I mean by that is like earlier in the conversation, we're kind of talking about, frameworks and how useful frameworks can be for, getting started or for like kind of building something that you might not know how to build the intricacies of. But I think an important thing that Bill mentioned is that, you can only use a framework to get so far. And at a point you start hitting up against the friction of using a framework. You start wanting to think, work around it or do things differently. And if you don't have that base level of knowledge and how that framework's constructed, then you can't go and kind of implement what you need now. You don't have that knowledge. You have to go acquire that knowledge. What I feel like a lot of this conversation has been kind of hinting at is that we need to be perhaps a bit better at focusing on acquiring that knowledge earlier rather than later, because it feels like a lot of these design philosophies are answering questions that we have to help ensure that we're all on the same page. If we're a team, that we're all on the same page, we are sharing the same amount of knowledge. And I feel like frameworks and the like of those things are shortcuts around having to do that process up front. Right? If you go and use a framework that has, specific opinions or specific ways it wants you to do things, you don't have to have that conversation with your team. And now you can just move on and write the code and ship the code. But I feel like this design philosophy conversation is pushing us to say, don't be so focused on shipping the code. That isn't necessarily the most important thing at the end of the day. It's important that we get the software into production, but that is different than like just writing the code or creating the code and how quickly you can create that code. And we should be focused on making sure that we're writing the correct code, or for whatever correct means. Correct might mean a smaller amount of code than we might have written otherwise, or it might mean code with fewer bugs by virtue of being smaller. But I kind of feel like there's this tension between having good developed design philosophies and having kind of using frameworks as a crutch. So I feel like that's what happens a lot. And I want to extrapolate on that a little bit more too. And I want to say, it feels like once those frameworks get out into the community as a whole, once those become established things, people start forgetting completely the fundamentals of those frameworks. And it becomes like a kind of knowledge that is sacred that only a few small people are allowed to know and use and practice. And I feel like a good example of that is HTTP frameworks. I've seen throughout my career a lot of people not know the history of how certain things that we do develop. For instance, clean URLs, how they developed, why we use them. And since they don't know that, they're like, oh, we're just going to apply these to APIs. And that's how we got this, wildcard thing that we keep doing in every framework, is like, we're going to support wildcards. If you don't support wildcards, then you're not doing it well. And I've always kind of sat and thought, and I'm like, but there's query parameters that are in most cases better than wildcards. You can do more, they're more flexible. Why don't people use them? And what I've come across is that people don't know how to design an API to use query parameters as well, because they've been using wildcards for so long and they've been so attached to these clean URLs that people love using. And I feel like that is a design philosophy misstep. That is, we didn't think about why we would want to have clean URLs and what the applicability of them is, because clean URLs are absolutely applicable in a browser. You want things that are easy and hackable for your users. Like, oh, I want to see all of the articles for this month, and I'm looking at one that has like the date. I can just chop off the day and then it'll give me for the whole month. I can chop off the month, it'll give me for the whole year. These nice hackable URLs that are a kind of handle for people to be able to use your website. But that isn't applicable to APIs. You don't have people like, maybe when you're just experimenting with an API, you're hacking around with it, but that's not the main use case of the API. And I feel like when we institutionalize the knowledge of things like that, and I feel like it was probably accidental at the end of the day. I feel like at some point people are like, oh, it's easier to get started if we have nice looking API URLs. I can just hack and get some data back that I can just play around with. I don't have to go write a little client library to do all this other stuff. It feels like something that was innocent that got in. And then because we all rely on frameworks so heavily, we wound up getting stuck with it and that becoming the thing that we should all do without actually going back and thinking about it.
Well, let's be fair for a second, right? Here's another design philosophy. Consistency in everything we do is paramount. For me, that's where we win or lose the game a lot of times in code, the consistency. And I think frameworks start out with the idea that we're going to create a consistent way to do things. So we have that, but eventually they get too big, they get too strong, and then you're stuck, right? And I think that's what happens there. Where if you look at my starter kit, we do have a small web framework, but it's super tiny. I'm never going to be putting up really large walls around it because we want that flexibility. But you need some framework and some patterns for the consistency of them, right? And so there's a balance there. There's a balance there that you need. But like Yana said this one day, like she said it on Twitter, and I wrote it down. And again, it's the same. A good API is not just easy to use, but it's also hard to misuse. So the framework is giving you maybe your macro level design philosophies kind of concreted in, but you still have to write business logic, even if you're using a framework. You still have to write handlers. You still have to write code. And so though maybe you don't get to apply your own macro level design philosophies around everything, you still have to have your micro level, like looking at API and going, okay, it's easy to use, but look at all the mistakes somebody can make with it as well. And how much nicer is it if you wrote a function that, and if you wrote a function I looked at and I said, look, an API is just not easy to use. It's also be hard to misuse. You could appreciate that because your brain can then start looking at all the engineering around that. And then I could say, Chris, go back and think about that and see what kind of instead of me telling you, right, a good design philosophy should not result in me now telling you what to do. It should result in you going back to your desk and being able to say, okay, how do I make this, how do I reduce the misuse or fraud in this API, right? And then you come back and now we're having that engineering conversation. We can play off each other there, right? Like that's cool. What I saw this tweet one day and I was pulling my hair out because I just don't think it's fair. These types of things I don't think is fair. Somebody tweeted, if you're not using structured logging, you're doing it wrong. Like that's not a design philosophy. For me, I always teach, you shouldn't start a project until you can answer this question. What is the purpose of the logs? What is the purpose? We all have different purposes. Like here's a core category. Do the logs contain data or not? If the logs are not going to contain data and they're only used for being able to debug the application, you don't need structured logging. You need logs that you can read that have a bare minimal trace and a lot of context for error handling, right? But if you're going to put data in the logs, this is where things get fun, right? Okay, no, we're going to put data in the logs. Fair. Choose a format. But if suddenly in this service you can't log for whatever reason, does the service stop? If you can't log because you're logging data and now suddenly the log is blocking, do you tell millions of people they can't watch that video anymore until the logging works again? If the answer is no, then you shouldn't be putting data in the logs because unfortunately, if you're putting data there, you got to log, right? But you see where we're going? Now we're having a conversation around, okay, so what is our philosophy around logging? What is our log's purpose? And we're going to make sure that we're using the right one. And then it gets to, well, who can log, who can't log? How do we know that somebody shouldn't log? And this is where precision comes in for me, because I will say, you can't use a singleton, not even the one in the standard library. You have to pass a logger everywhere in the app that you want to log. Why? So when I look at that PR and I see you change the function signature, or you change that type to now take a logger, I can pause and go, I see now they want to log. Are we even allowed to log in this layer? Oh, we are, okay. What are they logging? Is that signal? Is that noise? What's going on? Like, I don't believe in logging levels. I have never in 30 years been able to turn a logging level up fast enough in production for it to be valuable to me. So either you need to log or you don't. Like either you're debugging at your desk every day or you're not. So these are just a whole set of philosophies that allow me to now make engineering decisions about what we're going to do. If my philosophy is you're not allowed to use a debugger to debug this app unless you're stuck for 20 minutes, you can only use what you have available to you in production. Well, you're going to make sure that it's working for you at your desk, whatever you have available to you have in production. And when it's not working and you raise your hand and you say, I need help, we're going to figure out where it broke down, right? Again, that's to me a design philosophy, right? We don't use debuggers to fix bugs. We just don't. We use them to trace through code at times when it's code we don't know and there's no real clear mental model for this code base, but we're not going to use them to fix bugs. Disagree with me. That's fair, right? But that now drives a whole bunch of decisions around logging and metrics and what we're going to deploy and not deploy in terms of debugging and maintaining an app.
I feel like a lot of the time, the conversations around these things too become like not what you were talking about, like the actual like why and how should we, like why should we be logging, or why should we have these metrics, or why should we have distributed tracing? But it comes down to like, oh right, we've decided that we want to have this. Now what of these like 15 libraries that are available should we be using? And we don't even start the conversation in like the kind of the right arena or the right area. And I think that's kind of what I was trying to say before too, which is like, I think frameworks are a necessary thing, like they're useful, but I think that if you don't have the design, the discussions around them, and the design philosophy around them, they become more of a burden than a help.
So quickly before we switch to unpopular opinions, Bill, generics.
I'm a fan of generics. I think that generics are going to bring some really great things to the language that we don't have today that I'd like to see. Now you're going to say, Bill, what is that? I want to see a package in the standard library that can implement as many of the concurrency patterns that we all have to code ourselves. I think there's more bugs in Go code today because everybody's writing their own pooling patterns, fan outs, other complex things that could be coded by somebody on the language team, where you just pass a function or something, and you know that the concurrency pattern is solid. Like, so super excited about that. You know, the sync.map, look at the comments around the sync.map type. You know, somebody engineered that to be mechanically sympathetic with the hardware caching system that you don't get if you use a regular Go map. Imagine we could put a concrete type to that. I wouldn't use a regular Go map ever again, because if I'm going to be doing heavy map stuff and I'm going to get the mechanical sympathies of the caching system with that type, and I get to use a concrete type on top of that, woo!
Golden.
I think you're golden. You know, not a lot of us build container types. I'm not really doing linked lists, and we really shouldn't be. We should be using the slice, yada, yada, yada. But I think from a concurrency standpoint, there's some really special things. And in the cases where you are using an empty interface as the return type, because you are doing something that is legit, that is reasonable, you're solving a particular problem, and you had to use the empty interface on the return, I think there's home runs that we can hit with the generics. Now, remember, this is the first release in 118. If you look at what's been admitted, at least, there's still a long list, like compiler templates and things like that. I expect more over the course of 2 or 3 years to be added to generics, but I don't ever expect to have like what you're seeing in, say, C++ or something. And so, though we do also want to, and I say we, I shouldn't say we, but as a community, I think we should want more people writing code in Go. And if we bring in more of the larger enterprise companies that are using C# and Java, let's say, primarily, because they want to, for better or worse, do more with generics, I don't think it hurts to bring them in. I don't think they're going to get everything they want either, but I think they'll get enough of what they need to be able to consider Go for future projects, and that helps everybody. And I'm not worried about somebody abusing it, because we've seen a decade of people abusing channels, and we're still here. So we're going to survive. And I think the community is better suited to be able to share with people. No. Use runtime polymorphism here. Don't like. We weren't better suited to say that about channels because we were all so brand new. I think we're better suited to be able to kindly, right, be able to fix things in code reviews where we realize generics shouldn't have been used.
All right, that's a fair take. That's a measured take. So thank you for that. All right, it is time for unpopular opinion, y'all.
Unpopular opinion. You
probably leave.
All right, Bill, I know you came prepared for this. Hit us.
So this week, somebody named Emily Freeman, who I do not know, I don't even know I don't know her, but I just started following her on Twitter because she was just kind of saying interesting things. And I love that, right? I love Yana because she loves to say these interesting things. And even if I don't agree with it, but I actually agreed with what Emily was saying and I retweeted it. And what followed after was mind blowing to me. And if you go on my Twitter account and find that, you can see all the comments that end up, it was mind blowing to me. But this is what she said. And it seems that this is an unpopular opinion. She wrote, when people hire artists, they look at their portfolio. They don't hand them a canvas, some watercolors, and make them paint in front of an audience. And obviously she's talking about how broken the interview process is, right?
Mm-hmm.
And I really believe that the interview process is broken. And I'm not a fan of these projects that you necessarily have to take home. So just my opinion is this: if you have a strong portfolio in GitHub that you can share, and you're confident that body of work represents who you are as a developer, I think it's fair for the other company to take the time to look at that and then interview you against that body of work. The biggest arguments that I was hearing were people were like, well, I don't have any open source because I work all day, I work on private source, and that's fair, right? Like, we've got to find a way of being able to validate competency in anything we do. And then I think people should have the choice. You want to take something home, it's going to take you n number of hours. Do you want to do something live? I think people should have a choice to do what's can best represent them. Because not everybody can stand up in front of a whiteboard. You don't do that every day anyway. I don't know. So it was interesting, and the feedback that I got through her was a little bit mind-blowing. But
I know Chris is going to have some opinions on this. Before I yield the floor, I do want to say that there's an argument that can be made on both sides. And over the years, having been subjected to all those different kind of interviewing styles, I can see the merit for some, and in some cases, I've hated those interview processes. But I can understand why people think they work, and in some cases they might, right? Because the thing is, I think it's less the interview process, or I've come to learn that it's less about the interview process, which may or may not be sort of broken, right? It's more about, is it a good fit for the candidate that you're interviewing, right? So in places where I have control over the engineering process, or rather the engineering hiring process, I try to have at least two different styles of interviews. One where I make it an option for somebody to do a take home if they have the time and the inclination, they can do that. And then we bring you in and we actually have a discussion. You walk me through your thinking, your design philosophy, as it were. And that gives me an opportunity for us to sort of have a back and forth, right? As if we were pairing on something together. And then you have those who have been preparing, and they have the cracking the interview code book or whatever, and then they know how to do the whiteboarding. They can recite algorithms off the top of their heads. Maybe they just graduated school and all that stuff is fresh for them, or maybe they spend the time and money and effort into preparing for these styles of interviews, and they go into on the whiteboard and they ace it, right? And perhaps that's suitable for them, right? So I don't think there is a right way, wrong way per se. I think there is what is suitable for different people, and I think being able to offer, and not everybody can do this, right? If you're a small startup and you don't have the people and resources and money to do that, right? Maybe that's not right for you, but having different options that suit different styles of interviewees, right? Different candidates, I think might be for me might be the better approach, as opposed to having one way and basically trying to get signal from all the noise from a candidate for whom that's not well suited, you may be doing a disservice to your hiring practice. But that's how I see it. Chris?
Let's see. So I think that I'm of a few minds on this. First, I think that our poor interview processes show how much companies in general don't really understand what software engineering is, right? I feel like asking someone to sit down and write out some code in definitely when they ask you to sit down and write code in front of them, I think that's absolutely atrocious. But I think even take homes are a lot more noise than they are signal, right? You're going home, you're writing code by yourself, you're not collaborating with people. That's not what we really do at work. And I feel like a lot of even the better interview processes I've been through show that the company hasn't really thought about what the people they're hiring do and what they would like them to do. And they don't have an interest in figuring that out. Like, I feel like that's the core problem with this. Not so much that it's like, we want you to show that you know what to do, but that we don't really know what we want you to do. So we're just going to throw some random stuff at you. And we hope that it winds up being a good fit at the end of the day. I feel like that actually leads directly into the problems we see with like bias and a lack of inclusion, is because we have these processes that boil down to like, oh, did you do all the stuff to jump through the hoops so you're part of the cool club? Because we don't really understand how to do it better. And that sounds like a really tough thing to do, because we're going to have to look at our engineering process and sit down and figure out what it is we do. And that's an even bigger and scarier problem for us to solve. So I feel like the interview process is kind of like the little the thing that we can see that you can grapple with the easiest, but I think it shows the deep problems and struggles that we have as an industry. And I don't think that we can actually solve it by trying to solve it head on. Like, I don't think that there's a way that we can tomorrow come up with an interview process that is good and that will actually measure people's ability to perform as a software engineer well, except for maybe like the kind of junior or intermediate positions of software engineering. I definitely think we can make it better, though. As I said, I think that asking someone to sit in front of you and write code is not only just really silly, it's also extremely impractical, because that's how you get people that write hackathon code. That's how you get people that don't think through design philosophy. They're just going to bang out some code because they're under pressure and they've got 20 minutes to show you that they know this programming language. And I think, too, they don't actually tell you if someone knows a programming language, if that's what you're interviewing for. I can tell if someone knows Go by talking to them, because I've written enough Go that I know what to ask. So I can see, oh, you've been writing Go for approximately this amount of time because of this way that you're thinking about this type of challenge. But we're so focused on like, well, we need to have some objective way of showing that they know the language, that we forget that there's these far better, if more subjective ways of evaluating if someone actually knows the things. So I think, I think that's kind of my reaction to it. It's like, I absolutely agree. Like, the way that we do interviews is terrible and we need to fix it. But that is a very big ask for an organization to undertake, because it involves so many more things than just the interview process.
To one of your points, I seriously do not like hackathons. I was asked to judge one time and I said no, because I said, you don't want me judging this, because I don't want to teach people that it's okay to go into a room for 3 days and just program and then get a reward for that, right? Make it clear then that you're building prototypes, but let's not pretend that this is a form of production level engineering that we're doing. And I think that there's just too many people coming out of these hackathons thinking that this is engineering. No, it's prototyping under extreme time limits, which is great, but is that the engineer that you want on staff after that? And then to Johnny's point, yeah, I think there are companies and teams missing out on people each and every day. Some of the stories I hear, like the questions that were asked and what somebody do, I'm like, I wasn't going to pass that interview. I wasn't going to pass it, right? And I feel like from a Go perspective, I'm pretty knowledgeable. And yet I sometimes think, whoa, like, I wonder what would have happened if it was me, you know? So I don't know.
I've definitely failed some Go interviews, like just because, you know, I froze up or whatever when I was going through the process. And I'm like, I don't remember how to do this one thing right now. My brain's kind of locked up and now it looks like I don't know Go, but I clearly do know Go. So that's really, I think it's really problematic. I will also add that I think that one of the things we need to start figuring out as an industry is how to better break up what software engineering is. Because I think that there is this divide between like the more designy engineering parts of things and the more writing code and programming things. And I think they are different from each other, not one above the other. I feel like the structure of our organizations puts the software engineering things above the programming things. And as you kind of move up the ladder, you go from programming into more software engineering things, right? Like the software engineer 1 and 2 and senior levels are all about the like more tangible, lower level writing code, producing code, making that code good. And then we have like staff and above that's more about this like systems and how all the pieces of software fit together. But those are two very different skill sets. And I think we really need to start talking about like how do we separate those two skill sets and actually create not only interview processes, but like knowledge, ways for people to learn those different disciplines. Because I feel like so much of the time we get caught up in confusing the two of them. And when we don't separate that, we lose a lot of the precision that we can get from focusing on one or the other. And I think this is what makes it really hard to hire senior level or staff level software engineers, is because like you can't give them algorithms. Like that's not what they do. You can't even be like, here, write some code for me, show you, right? It's like, that's not what they're there to do. That's not what they're trying to accomplish. And I think more and more and more, we need staff, senior staff, principal level software engineers to tackle the problems that we're facing, because we just can't do it any other way. And if we have no way of hiring for them, then that's a really, really big problem for us as an industry.
What I want to do, Chris, when my time with Arden is, I would love to be hired as a coach. And every week, work with a different team at some company to improve the design philosophies and the engineering and what they're doing, right? Not sit down and write the code, but to be pairing with them and teaching them. And I think this role is incredibly critical moving forward, but there's a problem with this role. At the end of the year, when your performance review comes up, you've got nothing to show for it.
No commits.
Right? You have nothing, right? No commits. No, not this, no, that. Oh, you had a conversation with a handful of people. And the few times I've heard somebody have this role, it's tended to end in a year, because during their performance review, it looked like they added no value when they probably added ridiculous value, right? And so there's a whole nother show that you should have here about performance reviews and how consuming they are sometimes around January through March, right? And trying to intermix things that you're doing that maybe not even part of your job, but you have to, because you know what's coming at the end of that year, right? You have to show some metrics. That's a whole nother story, but there's roles that are missing in engineering because there's no way to collect data on that.
Yeah, I feel like you're absolutely right there, but I feel like even more importantly is that those roles add way more value to the organization than like even like one of those quote unquote 10x engineers that really just make a giant mess can add for your organization. I think that is a chronically problematic thing that we have, where we just can't evaluate the people that amplify what other people can do. Because at the end of the day, like, you know, if you have 10 engineers and you're going to go hire another one, then, you know, would you rather hire one engineer that gets you, okay, now you have like 1x more, or would you rather hire someone that can like increase the productivity of your other engineers by some amount through many different means? And if you can do that, then you get more engineering power with having fewer people. And there's also all of this stuff around, which is probably part of this episode, is like the chronic thing where people are just like, we're just going to hire 40 engineers and not think about how to manage them or grow their careers or anything. Yeah, there's definitely a lot to talk about around this.
But you get code quality, you get your consistency, you get everybody on the same page with design philosophy, which is what we were talking today. And you don't try to do it in a week. You do it over the course of 3 or 4 months, right? That's the point.
Indeed.
I have a unpopular opinion that I will drop and run away from really quickly.
Ooh. Do
it. We're probably gonna have to talk about this a little bit, but that calling Golang is a respect problem and causes major inclusion problems within our community.
So
Really?
let me wait. I need more on that.
Okay. So here's the line I'm thinking behind this, right? The language's name is clearly Go. It is Go. That is what the authors have called it. That is what all of the documentation says. And calling it Golang shows that as a member of this community, you don't have the level of respect to actually call something by the name it is intended to be called by, which I think if at a level, and this is like trying to draw a line too far, but I think at a level, if you can't call something that you're voluntarily being part of by the right name, how can we actually expect you to call other things by their right name? Which is where I get to the inclusion problem of like, how are we gonna, if you can't call a programming language by their right name, how can we expect you to call someone by the correct pronouns? How can we expect you to call someone who transitions and as a prominent member of the community by their correct name and not dead name them, right? And that causes lots of problems with inclusion at the end of the day. And I think that it seems small, it seems tiny, but if you can't get your head around that, how can we really trust people to get their head around these bigger things?
But let me ask one question to you, because I think the problem here is, though the language team early on made it clear that the language's name is Go and not Golang, right? Like they made it clear. The problem is too many people, and we've got 1 million people here coming to the language. Their first interaction with it is the search term Golang. It's like their first interaction with it. And so from their perspective, I use Golang on Google and all this stuff comes up. And so they kind of just transfer the name along. I think it's done innocently. I don't think it's done I think it's done out of ignorance, because if you just type Go, you may not necessarily see the same results as Golang, right? It became the search term. What I would like us as a community to figure out is, how do you kindly, with the largest amount of kindness possible, tell somebody, yeah, I understand why you're saying Golang, but if you're gonna do anything official, just the name of the programming language is Go, right? I wouldn't tell anybody that unless they were writing something or they were putting slide decks together, or I think there you can do some correction. But I think there's a gray area here where that's their first interaction with it.
I agree, partially. I think I'm not saying that it's disrespectful from malintent. I'm more saying that it's like, okay, you thought it was Golang because you Googled Golang to find something. Someone has now corrected you. Commit it to memory that is what you should call. It's the same thing with people's names, right? I mean, I pronounce people's names wrong multiple times, and it's like, okay, you pronounced it wrong, you got corrected, please pronounce it right. Or spelling people's names. But I also think that leads to, like, at the end of the day, if we're writing software, we're writing really complex things that have a lot of nuance and a lot of precision, as we've been talking about. If you can't separate out, this is what I use to Google it, but it's not its real name, but it makes it easier to Google it, from this is what the thing's name is, I think that's a problem for us as a community when it comes to precision as well, right? Like, I think this is something that has like those tentacles that keep expanding out the more that we kind of discuss it. And I think as you said, it is something that we have to figure out as a community how we want to solve it. Because I have run into some very flagrant and stark opposition to calling it Go from people that are like, well, the website's Golang and I write Golang when I Google for it, so its name is Golang. I don't care what you say about its name. And I think like that's the extreme end for sure. But it all trickles down, and we got to be real careful about where we allow that to be a component. And I think simply put, like I think most people, if you're like, hey, calling going is disrespectful, please call it go, is a pretty basic place to start. But the reason I think it's an unpopular opinion is because I think a lot of people are going to have hot takes and say, no, I think you're wrong. We should be able to call it whatever we want.
And that is that. Thank you so much, everybody, for listening to the show and contributing on Slack and Twitter and things. I do want to have one last sort of parting set of words. Going back to the whole interview thing, it is something that always generates a ton of discussion. Some for and some against. With regards to the different styles of interviewing and whatnot. But rather than trying to solve that on the show, really, my message really for those who are subjected to the interview, these interview processes, that if you go through an interview and they use a particular method that is ill suited to your way of reasoning and thinking and communicating, it's not an indication that you are incapable. It's not an indication that you can't engineer things, that you're a failure, that you don't know what you're doing, that you are indeed an imposter. It simply means that the method that they're using to calibrate your skills is not well suited to you and how you learn and how you communicate. So don't beat yourself up too much. Just move on to the next. And if you don't get your dream job, that's okay. Maybe it'll come back around again in a couple of years. But yeah, keep your head up. And interviewing is hard for both interviewers and interviewees. It's a challenge, but it's not a reflection on you and what you're capable of. So with that, I say thank you for your time and listening, and we'll catch you in the next Go Time. And this is where Jared goes. There you go.
And this is where Jared goes.
Okay,
Nice.
I want this to be unpopular. I keep failing with my unpopular opinions that they keep being popular. I'm like, no, it's not supposed to be Stop
That was a
voting
good
for it.
episode of Golang time, guys.
There wasn't much chatter on Slack, so I don't know what that means. But I guess I wasn't there to cause disruption.
It's weird. Like some days it's really lots of chatter, and some days it's not. And I can't really. There's no rhyme or reason. But
In the flow of things sometimes.
yep. I was listening along, and I was enjoying it a lot.
That
I'm
hour
glad-
went fast.
I'm glad I wasn't on it.
Mm.
I'm glad I said no, because y'all had lots of smart things to say, and I had nothing smart to add. So
Oh, but I'll send you that, or Johnny, the document with the
Yeah, I've got-
thing, so-
I got that linked in show notes.
all right.
sweet.
I feel like we're gonna have to do an episode now on performance/interviews.
Yes.
I feel like this is gonna be hot discussion.
I think we do one like almost every year or something. Yeah, it keeps coming up again and again.
'Cause everybody
One of the
does that.
things I made the team and my company now moving forward is if somebody doesn't get a role, I've made it clear that they need to tell that person why, so they can improve on the thing that didn't let them have it, and then give them that opportunity to come back. I've been really kind of hitting my team hard on that, because I don't think it's fair to tell somebody no, they didn't do well in the interview or they didn't pass and not tell them why, because then how are they going to improve themselves? This isn't like, it's not to make you feel bad. It's to give you that opportunity to
Yeah.
figure out what to work on. So at Arden now, you're told specifically what it is that you didn't do well in the interview or what was lacking, so you can come back and improve on it. It's not always technical.
Right.
Sometimes it was like this person just came off abrasive, or this person, right? And so sometimes we have to ask our clients too, which helps us as well, because we're like, oh, what's going on? They did great in our interview. What is it that you didn't see? I would just like to see more companies do that. I know it's uncomfortable, but you're not helping anybody if you don't.
I feel like good advice for people too is that, like, remember that you're interviewing the company as much as they're interviewing you. So that's something I heard a lot, but it never really internalized for me until like the past few years when I started like interviewing at places and being like, okay, well, I did get an offer, but like this isn't the offer that I was looking for. This isn't what I wanted. And being like cognizant enough and like thinking about it enough to be like, okay, well, this isn't what I'm looking for, so I'm gonna have to pass on this, even though it like is maybe a good offer for someone else. It's not a good offer for me, or it's not really what I was looking to have or what I was looking to do. So I think, yeah, a lot of the times it does feel like the interview process is so lopsided where it's like the company is the thing that matters and you're just kind of a pawn here and you don't have any influence or say in it.
Those
But
aren't
I
the
think-
places for you.
Yeah. But I think the perf conversation is interesting because I'm sure somebody has figured out things that they do throughout the year to help them with their performance metrics that maybe others don't even know about.
Mm.
And, you know, there are things that we can do as a community to help the Go team as well, by the way, that maybe we can bring Carmen on to talk about.
Yeah.
Because it helps them when they can show that they've been helping the community. And so, you know, what can we do to help the Go team internally show success? There are things that we can do. There are metrics that can be applied.
Slightly off topic or slightly unrelated, but another kind of review. I would love an episode on code review, like how to do that well versus bad. Because I don't feel like I'm very good at it, and I would love smart people to tell me. Like
It's a skill like everything else.
I know.
And a lot of what we talked about goes into that code review process.
Yeah,
So
that's why
when
I thought
see
of it today. I was
something,
like, man, this could be like even just this particular aspect of things by itself could be a conversation. But a lot of good stuff, Bill, came up today on that topic for sure.
That's like in that too.
Chris, your gain dropped for some reason, like towards the end of the show.
Oh, okay. Well, I think I saw it was peaking in Audition, so I like tried to tune it down some, but I might have tuned it down too little.
I thought it was Zoom that was doing it to us. That's why I didn't mention it. I figured your local was still good.
It's not like super quiet. It's like easy to like just raise the gain on it. It'll be fine. What was I saying? Oh, like one of the things that I actually had like a brief conversation with Sam Boyer about was I think there's like kind of I think there's like a spectrum of people that write software, from people that like really love to write the code and people that really like to do the software design. And then there's a bunch of people in the middle. And I feel like the processes we have and the positions and the roles we have optimize very heavily for the people that are in the middle and not for the people that are on the edges. And I feel like a lot of the time we need more of the people that are on the edges. I'll give an example. Like I think a few jobs ago, there was someone I knew who was like an extremely talented engineer. He could write really good code, absolutely loved doing it, loved coming into work, loved writing code. And he didn't care at all about the hierarchy because he was just doing, you know, what he loved. And they kept pushing him, be like, okay, well, you should try and like move up the ladder. You should try to advance. You should try to get further. And he was just like, I'm not interested in that. I'm doing what I love to do. If you can like help me grow along this aspect, then sure. But I'm not interested in being a manager. I'm not interested in doing big level design stuff. But they continued to try and like shove him up the ladder to the point where he, I think, eventually became unhappy because he got into a role where he didn't want to be. And I think on the opposite side of that is people like me who like, I like coding, but I like designing a lot more. But I found earlier in my career, it was more difficult to kind of find the roles that were more about the design, because those roles are typically associated with like staff or senior staff level roles, which are, as I said before, like difficult to hire for. And I feel like that's like a conversation that just isn't had very often. But I think like from talking to a lot of people, I feel like that is something that many people feel at the end of the day is just like, where do I fit within the organization, and how do I enter at the right level, regardless of like the experience that I have? Because as I said, I think it's like we have this hierarchy where we assume you start at writing code, and then as you go up, you write less code, which I think is like an inaccurate way of framing everything.
Mm-hmm. Interesting. I'm just over here thinking about low code and no code, because these are things that have been, I'm like, at what point do you write no code? And then how much no code do you write? Because
I'm at a no code level now. I just don't want to be, you know what it is at my age at this point? I don't want to be responsible. or anything running in production anymore.
Yeah.
So I rather coach and mentor and like
Yeah.
go home and know that I'm never getting a call at 3 a.m.
Yeah.
Oh, I know
Oh,
Johnny's
man.
going to call me up anyway. Bill, you remember
Johnny's
that
got-
design philosophy you told me about? And I wrote that code. Yeah.
Right.
Get in the office right now.
Yeah, it's broken right now. I need
It's your fault. Philosophy broke production.
Yeah.
Bill, bad Bill.
Yeah. We got a philosophical problem over here.
Oh, I also feel like there's another access to this as well. That might be an interesting conversation we could have at some point. Around people who like writing greenfield code and people who like doing maintenance. And I feel like there's so much of a stigma toward, well, you should like writing greenfield code. And I have friends that are like, just give me some old code base I can like keep running and touch up over time. I don't want any of that greenfield, like brand new project stuff. Please, no, thank you.
Too many decisions to make.
Yeah, too much. And it's also just like, I don't know, like greenfield stuff is like, you just introduce tons of bugs as you're flailing around trying to build something. It's like, sometimes it's nice to just sit down with a code base and be like, learn it deeply and be like, I know where all the problems are and I'm going to fix them over time and just make the thing better. But I feel like we are very biased toward like the hackathon, can you crank out code faster than anybody else? Can you build a new system faster? Or like this system has like a couple of bugs in it that are major. So let's throw the whole thing out and build a new one. Which is always never.
Back
never
when I was
works.
consulting, I did a lot of rescue projects. I just loved that work because like you walk into a dumpster fire and hopefully you can fit some sort of test harness around it, so that at least that it works the way it currently works. And then you just like slowly, surely figure, it's almost like you're a detective, figure out what's going on, like how to,
Therapeutic.
it is therapeutic. And then when you improve it, it's just like feels so good. I used to love those projects.
I call it chaos engineering, which is a lot of the work that we have to do sometimes. You're walking into a chaotic situation. And either you have it in yourself to handle the chaos around you and then bring it down, or there are people who walk in there and 3 days later, they're like, I can't do this.
Yeah.
Yeah. And I think it's like something that companies have to like think about more themselves too, of like, what's our balance of the types of engineers we have and like what are the things we actually want to do? Because if you hire too many of those hackathon engineers, you're going to be rebuilding the same system like 7 times and you're never going to turn off the old one. And you're going to have 7 versions of the same thing that do slightly different things. And you're going to be like, why do we have 7 we need an 8th one. It's like log 15. We need another version of this that will replace all of the other versions of it. We'll get it right this time. We promise. Meanwhile, the poor maintenance engineers are sitting there being like, if you just listen to us, we wouldn't have 8 systems. We'd have one that's beautiful and gorgeous.
Oh, you know what's really fun, by the way? To be an SRE on call, doing an incident command at 3 o'clock in the morning, production system that is globally distributed with lots and lots of customers on it right now. Yeah, that's really fun. If you
that's why you make the big bucks, Johnny. That's why you make the big bucks, Johnny.
Yeah, you couldn't pay me enough anymore. I'm too tired for that.
I'm always like, I am not someone like I'm a heavy sleeper. So I'm just like, anyone that's like, would you like to be on call? I'm like, if you're okay with the system just being down while I'm sleeping, then sure. If not, then you probably shouldn't put me in that on-call rotation. There are people that are much better suited to doing this than me.
So in the late 90s, I used to take the phone home for this kind of stuff, but they would pay me an extra $500 for the week to have the phone, and I needed money back then. So and nobody wanted it. I was like $500. I'll
do it.
And we started eventually we started fighting over the phone. Right?
Yeah.
But today I found out like you don't get any extra money for taking the phone home.
No.
And I went, what?
Yeah. Why would I take this phone?
No.
Why would I ever take it? If
That's part of the job.
No. Somebody in my era realized that they should make it part of the job. But we all pushed back. I remember like, there's no way we're doing that. It's going to be $500 for the week. And if you got 3 phone calls at night during the week, it was a lot. So it was like this, back in the late 90s. So I make an extra $2,000 a month. Whew, it was like huge.
There's still a part of me that's like, can we start writing software that like never falls over at night or almost never falls over. We can still have the on-call people. I'm not saying we need to get rid of. We obviously cannot get rid of SREs and on-call people. But like, can we just write software that like doesn't fall over as much, please? It feels like
they're called PBXs, and the
Turns out no.
Israelis did that like back in the day. They were
Yeah.
amazing software engineers. Those
Hmm.
PBXs are failing all the time, and you have no idea.
No idea.
No idea.
Were they written in Golang or something?
No, I
I
don't
mean,
know what
no,
they were
not
writing.
not Golang. I'm going to say.
Oh, no respect, Johnny.
Where's your respect, sir?
I had a guy in the 90s that I worked for. He's an Israeli engineer, and he was applying all of those principles that they were using in the PBXs to things we were doing around microservices at the time. And it was just like, he showed me the box one day. You see that box? It's failing right now, but you don't know it because we've coded it, so you'll never know. They
should
can
have
rip
wrote
boards
that.
out and put
When they
boards
write it
in.
down for us, they should have, put it into a class or something for us.
The don't fail class.
Yeah,
We
like
were there,
just-
Chris. We were there. Somehow it got lost.
Isn't that
We were
where
there.
like the philosophy behind Erlang was like,
Yeah, let it fail.
make it so it like fails and it doesn't need some human
Yeah.
to come in and intervene.
Yeah.
I feel like there's a lot of software we do right that's like it either fails and it recovers itself or just like doesn't really fail, but that's all like the low level, like the software in your car, which you hope you don't require an SRE to fix. Although,
So here's the thing. I think you nailed a particular topic I want to have a discussion on this show at some point. We call ourselves engineers in this field, and the people who are like civil engineers or mechanical engineers or even architects, like people have to deal with like systems that if you have a hiccup, right, and production costs lives, right, a shuttle blows up or brake pedals on an e car or something,
Bridge
fails,
falls
or
down.
a bridge, like these kinds of like that stuff. I'm not beating people who call themselves engineers. Heck, I call myself a software engineer. So I think there's nuance in that. And I think we over time have gotten used to almost like this let it fail thing. Like it's okay. The stakes are low enough that if this particular service crashes, we'll just, rely on some other daemon to start it back up again. Or it's okay to basically, the orchestrator will put another a container back in, or we're used to basically the like tools picking up the slack for us, so we don't spend as much time engineering like quote unquote solid pieces of software.
But
There's
here's
a
the
lot
design.
of low stakes software though. I mean, a
Here's
lot
a
of
d-
what we do is like, let's take this, what used to be an Excel spreadsheet, and put it on a web app. Like that's a lot. Well, a lot of businesses like that's what they need is like,
yeah.
and so like, I mean, maybe 80% of software that's web software is like that level of stakes where it's like, you know what, if this form doesn't work with 7 nines of reliability or whatever it has to be, like, yeah, it's law of diminishing returns on that effort, So I get where and in some other cases, it's like we should do a lot better, of course.
Here's the design philosophy.
Okay.
You are responsible for the software you write. I firmly believe that, which is why I will never work on self-driving cars.
You don't even want to wake up to
hands off.
Dude, no, you are responsible for the software you write and the software you deploy. You are personally responsible for that. I honestly believe that.
That's why Bill writes no code anymore.
I know, right?
He's over here, hands up.
I wrote a piece of software back in the late 90s that somebody died because it failed.
Oh boy.
I've been there, dude. I've been there. Like I've worked on those systems. I did my time there already.
Wow.
But I think people need to have that philosophy embedded in their head. I talked to an Uber engineer that was working on driverless cars, and I said that to them one night at dinner. I said, you're personally responsible for the software you write, and I don't think that software I can get involved in right now because I don't understand all the legal issues. And he basically like called me out for not wanting to do it. Called me out like I was somehow
like a wimp or something.
Yeah, for lack of a better word. But
yeah,
I kind of feel like too we're really bad at telling like what software is like life threatening. Like I feel like, the business stuff we were just talking about, I feel like there's so many times where I've like gone into a place where like someone wrote something that some business person uses and it works flawlessly for like 7 years and then it breaks. So that's like a whole other problem.
Yeah,
But I
bit rot.
feel like there's a lot of software that we do write that we feel like isn't life or death type of software, but winds up being like, I'm kind of thinking of like, Facebook doing that thing where they psychologically manipulated people. It's like there were engineers that wrote the code that allowed that to happen. Do they feel responsible? Or like the bigger problems where like, Siri, if you said some certain things about like wanting to take your life or being assaulted, would laugh at you or tell a joke. And it's like, yeah, that likely caused some people their lives. So
Right.
like we have to understand that like, yeah, if our software doesn't work, it's not just like, oh, it's just a web app, so it's okay. It's like that could have real effects on people's lives far beyond what we think it is. I think we have that sort of responsibility to be a bit more careful, even if we can't, for some reason, imagine the repercussions that come after what we build, especially with AI. I despise AI so much because of this, because people like cannot think of the repercussions of like the AI you write, of like, how can it harm people? How can it harm minorities? You should always be thinking, how can what you're writing harm minorities? Because more likely than not, it will harm minorities in some way if you don't explicitly figure out how it can harm people.
We were clearly naive to that, and I feel like people are waking up to that reality more now than they were probably 3 to 5 years ago. So I feel like there's an upward trend on like that, at least in the zeitgeist of being problematic, and I feel like people are trying. I also edit practical AI, and like that kind of stuff, they talk about it all the time with lots of different guests, like more so than they did when the show first started. Like it's becoming in the zeitgeist of developers for sure.
I used to teach that in the beginning of all my classes. If your cell phone went down today and everybody's phone in the United States went down, how many people are going to die in the next hour? And the answer isn't zero. I used to always ask that question. If that phone stopped working for everybody in the United States for the next hour, how many people are dead? And the answer isn't zero. And because of what Chris is saying with the mental health issues we have in this country, your bug could be the last bug that day that just finally caused somebody to just go over the edge, right? And that goes back to, you are responsible for the software you write. Integrity has to be your highest priority at all times. And we're an industry where we're not even licensed to do our job, and yet people's lives are in our hands every day. How long do you think that's going to last? How long do you think that's going to last? It ain't going to last much longer.
I did read an interesting thing, an interesting series of articles that ask the question of like, are software engineers engineers? And from talking to people that were other types of engineers and became software engineers, the answer wound up being yes. But I think an important part of that was they did ask the question of like licensure. And it turns out that there's a relatively small number of engineering fields that are really licensed. And the way the licenses work in those fields is often quite different than how we conceive of those licenses working, depending on it. But it definitely seems like, I mean, I agree with you, Bill. There needs to be some sort of like, not gatekeeping, but like some way of showing that you have the knowledge that you have, or like holding people a bit more responsible. But I feel like a maybe perhaps better method of that is to like instill that in us as an ethos, as software engineers, of like not being like, you're going to lose your license because you wrote this code wrong, but like, no, we're not going to, like, I don't know if it's like, we're not going to hire you. We're just not going to use the code that you write because you didn't take the care to actually focus on, things that could harm people, or you didn't think through your code well enough. Because I think even if we did all of a sudden have licensing in this industry, how much of the time is it individual engineers that are causing the problems with our software? How much of the time is it a product person or a business person said, no, you can't have the extra 2 weeks, or you can't have the extra 2 months to write this the correct way. You need to write it well, and you need to ship it now. And we're going to force you to do. And how much of the time do our processes that we love using, we love agile, but how much of the time do we say, well, we're moving too fast, we need to back off a little bit, and we need to reevaluate things? I feel like that's the problem that we really have to solve as an industry, even more than just the individual responsibility. We have to start having system and group responsibility around these types of things.
So this is interesting. I have a friend who works at NASA here in Huntsville. And when, I was asking him what he thought about the SpaceX stuff. And he's like, NASA's funding like almost all of that, right? I said, no. I said, why are you not doing it at NASA? He said, we're not doing it at NASA because all engineering at NASA has to be at a standard of human life.
Mm.
And if they had to do that now, they wouldn't be as far as they are. So they get to do engineering without the worry of what happens when we put a human life in that rocket, when we put a human life in that capsule. Eventually now they're going to have to go and start the engineering process for human life, but they get to move faster where NASA doesn't get to move faster, right? And so I think when it comes to like Department of Defense and NASA stuff, there's like these processes kind of in place already, checking the code and checking the systems that we're not using in industry. But I just wonder how long it's going to take for what the Department of Defense is already doing and NASA's already doing for human life level, like, you know, review to eventually get into our industry, which means before we can deploy something, maybe it has to run through a gamut of software checks and other things that I don't know what they look like before you can certify it as, I don't know. I think it's interesting, right?
I've worked in kind of regulated fields a few times, and I think the thing I've always found interesting about it is that their assumption is that having regulation or having, you know, to deal with that type of stuff will slow you down. And I think that's true in like the very, very early stages before you've developed the processes and systems. But I've always found that once you have those processes in place and you've kind of made them run well, you wind up in a situation where like you're actually moving perhaps a bit faster in the kind of macro than you would have been able to, and you have fewer bugs and fewer problems. So I wonder if it's that we need to take the types of processes that the DoD has and NASA has and kind of adapt them and innovate on them in a way to make them still as robust, still as safe, but faster and easier to implement for people. And I feel like right now we're just not doing that because we're stuck in this thought pattern of like, well, what we do, not having regulation, not having these standards we have to follow, that is faster at the end of the day. And I feel like that's the first step we have to get over, is realizing that like, no, that type of constraint can be helpful for us if we embrace it. If you don't embrace it, then you're going to be miserable and you're probably going to build some really bad stuff. But if you embrace it, I think it can be super empowering.
Well, are we really just talking about sort of what you're optimizing for here? Like I remember back in the day, we used to talk more about the sort of the software triangle, where each side corresponded with one of quality, speed, or cost. Right? I think if you're optimizing for quality, then you're probably going to suffer one of those two other areas, right? Either cost or speed, right? Like you can't have one. It's a compromise. Everything about software, whether you're writing the next, you know, Cash App or whatever, or trying to put someone on the moon, and I can only presume here. Obviously, I haven't worked in that field, but I imagine that they have some sort of optimization, right? They're optimizing for something, right? So I imagine for you know, places like NASA and SpaceX and the like, they are optimizing, you know, for something, right? So we optimize for different things, I think, generally speaking.
Yeah, I think too. I think the thing that when I think about that, I'm always just like, okay, well, there are these three things that we're optimizing for, but I think there are scales of those three things that we're optimizing for that I think we sometimes don't take into account, right? It's like, okay, well, like you might optimize for cost or correctness, but it's like, okay, well, you can kind of adjust these kind of levers a bit to kind of get like the optimal cost and optimal correctness. And I feel like that's the kind of like the next step we need to start having these conversations is like, what are those scales and how do we start measuring them?
I got to get out of here. I love this conversation. This is a whole nother show we just had.
Yeah.
All right.
All right. Yeah, we should also say
but I got to
goodbye
get
all
out.